Good morning to all of you. Myself, Professor N.V. Adpe from SNT College of Engineering and Research Center, Regula, working as an assistant professor in electrical engineering department. So, in the previous lecture or previous video, we studied the method, the solution of transdental and polynomial equation, the methods, various methods, that is bracketing method and open bracketing method. Again, what is transcendental equation and what is polynomial equation, like that. These are already studied that. And also we studied the one topic, that is bisection method to find the root of equation. So in that lecture, we studied the next method to find the root of equation or to find the solution of equation by using false position or regular falsi method. As false position method is a bracketing method, it is also bracketing method like a bisection method. Two roots are assumed such a way that they satisfy the condition, that is f of x1 into f of x2 is less than 0 according to the intermediate value theorem. We have considered in bisection method the approximate value of root lies at the midpoint or half interval of two initial guesses, that is x1 and x2. Means in bisection method we can find the next value of the root is the middle value, that is a plus b upon 2, it is equal to c. But in that case, these 2 points, that is f of x1 and f of x2, these 2 points are joined by the straight line, and this straight line cut the or intersect x-axis at this point. This is your the next guess. This is your first approximate value of root, that is x3. This which will be shown in as shown in figure. This is your figure x, y. Suppose these are the two initial guesses x1 and x2. This is your graph. This is your exact root of that equation, that graph. Then this f of x2 and f of x1 at that point x1 and x2. Then these 2 points are joined with the help of straight line, and this line intersect x-axis at this point. At those points, this is your next case. This is your next root of the equation, that is x3, and the value of y3, that is f of x3 is this is your f of x3. In next iteration, the we select the two guesses again with the help of again the condition check, f of x1 into f of x2 is less than 0. In that case, f of x1 is negative, f of x3 is positive, then the f of x1 into f of x3 is less than 0. F of x2 and f of x2 and f of x3 both are positive, means the product of both, it is greater than 0. It is greater than 0. That's why we select the guesses for the next iteration, that is x1 and x3. x1 and x3. Then by using these 2 points, we check the next iteration. But the value of x3, this value of x3, how to find this value of x3 by using equation? They will be derived in the next slide. As shown in figure, a straight line is drawn from point y1 and y2. The line intersects x-axis at x3. Therefore, we have located false position. This is your false position of the root at x3. So x3 is the first approximate value of the root. This is your first approximate value of the root. And again, to find the x4, this is your second approximate root of the equation. For point 1, 2, at the coordinate of point 1 are x1 comma y1, and point 2 are x2 comma y2, and point 3 are x3 comma 0. All the 3 points satisfy the equation of straight line. Therefore, for point 1, 2, and 3, the equation of straight line is given by y3 minus y1, y3, this is point, this is 1 point, this is your second point, this is your third point. The value of y at that point is 0. Therefore, y3 minus y1 upon x3 minus x1. Sorry, y3 minus y1 upon y2 minus y1 upon y1 minus y2 is equal to x3 minus x1 upon x1 minus x2. x1 minus x2. From this calculation, cross multiply, then minus y into x1 minus x2 is equal to x3 minus x1 upon x1 minus x2. This is your cross multiplication. The minus y1 into x1 minus x2 is equal to y1 minus y2 into x minus x1. Then multiply all the terms. Minus y1 x1 plus y1 x2 is equal to x3 y1 minus x3 y2 minus x1 y1 plus x1 y2. Minus x1 y1 minus x1 y1 get cancelled. Then y1 x2 minus, then y1 x2 is equal to x3 y1 minus x3 y2 plus x1 y2. All the terms of x3 and y1, the terms of x3 are in one side and other terms are in one side. y1 x2 is equal to y1 x2 plus x1 y2 minus x1 y2 is equal to x3 common y1 minus y2. Then x3 is equal to y1 x2 minus x1 y2 upon y1 minus y2. Means from this equation we can find the value of x3 with the help of y1, y2, x1 and x2. We can find the value of x3. This is the first approximate root of the equation. x3 can be calculated from this equation. The procedure to find the root of equation by using Regula falsi method. Let the curve be y is equal to f of x first. The actual root lies where the curve intersects x-axis like bisection method. We have to assume two initial guesses x1 and x2 in such a way that f of x1 into f of x2 is less than 0. f of x1 into f of x2 is less than 0, or y1 into y2 is less than 0. When the condition f of x1 into f of x2 less than 0 is satisfied, then we approach towards the actual root using false position method. That is first value x3 is equal to x2 y1 minus x1 y2 upon y1 minus y2. This is the, again repeat this all the terms from this. Check f of x1 into f of x3 is less than 0, then take the next the guesses for next iteration, that is x1 and x2, and from this we can find the values of, find the exact root of equation. Now we find the value of y3 at f of x3 by substituting the value of x3, and again check f of, if f of x1 into f of x3 is less than 0, then take x1 and x3 for the next iteration, or f of x2 into f of x3 is less than 0, then x2 and x3 is used for the next iteration. So this is your procedure to find the next iteration by using Regula falsi method. Find the root of equation by using Regula falsi method. This is the one example. Suppose a root, the equation is given, the transdental equation x raised to x cos 3x minus 0.5 is equal to 0. Between lies between the limits x1 is equal to 0 and x2 is equal to 0 with accuracy of 0.01. The initial guesses is given. Find f of find y1 and y2 at x1 and x2. Then by using the formula, that is x3 is equal to x2 y1 minus x1 y2 upon y1 minus y2. From this we can find the value of x3. Again check this condition and again repeat the process until the error is, accuracy is 0.01. So this is your regular falsi method to find the root of equation. In next lecture we will see the next topic, that is Newton-Raphson method to find the root of equation for one variable and two variables. So thank you.